Hey guys, someone asked me if I can explain the A11VO or LO LR control. LR means power control. Um, I think guys that I explained that when I explained the K3V, the principle is the same when it comes to power control. um, I think the power control is there so that to avoid uh, the driver or the drive unit, which is the engine or the electric motor going to stall. um, so meaning it maintain the constant speed and constant power of the drive unit without stalling. So I have here show you I have here the this one is the LR power control. It says there that the power control regulates or control the displacement which is the size of the pump, um, and then depending on the operating pressure so that a given drive power is not exceeded at constant drive speed. So here guys, this displacement here, which is the size of the pump, okay, which is the um, um, stroke times the area of the piston times the number of pistons. So that's the displacement, which is the cc per revolution. That's on your swash plate or cam, okay. And then that one will control according to your operating pressure. So the operating pressure is depend on your load, and then to control that displacement, obviously through control regulator or valve, which is the spring is adjusted according to your drive power. Okay, so I will explain at the whiteboard guys here. I'm gonna get my this one. We need this because to explain this. Okay, so this is the circuit diagram of A11VO because there's no boost for your, or there's no impeller for your suction. Okay, so this one size 40 and 145. Okay, all right. Now the way it works guys, okay, I think this is too easy. Okay, let's trace the pressure. Okay, that's the pressure here, or system pressure. This is your discharge. Okay, all right. So there, and then goes to A port. Now A11VLO at neutral, the pump is stroking. Okay, stroking because of the spring. Okay, now we trace the pressure, system pressure. See here, it's that, so meaning it's joint. So there's a small gallery. Okay, that one there. So this system pressure, this is pilot, but it's a system pressure. Okay, go all the way here. Okay, all right. So waiting for this spool to open. Okay, so that's blocked now. Okay, that's closed at the moment at neutral. So this is the LR. Okay, now at the same time, see here, there's a dot, so still continue, still connected. Okay, through orifice. That orifice is to slow the stroking time. Okay, that the rate. Okay, now here This is the interesting here, guys. Okay, here, this is the stroking piston, and then in the stroking piston there's a drilling. Okay, that drilling that will connect to your field this area here. This is your feedback piston or rocker cam. Okay, so this is only a small piece, guys, that act on the lever. This is the lever. Okay, here, so there's a ruler there. Okay, so you will see that on the, when you remove this control, you will see that. Okay, it's just a rocker thing. Okay, and then the area behind is, there's a pressure acting, high pressure, system pressure. Okay, so that's it, system pressure. And then, okay, now we're tracing now the, okay, I'm gonna get a new color. Okay, hang on. Okay, now we're tracing now the stroke piston. Okay, so here, so okay, and then you can measure here if you have a gauge, so you can measure that pressure. Now, through orifice to slow down the stroking time. Also, you can measure here M1, and then feel that area there. So, okay, now as you notice, guys, this stroke piston is bigger area than the stroking piston. Okay, so here the stroke piston is common to tank or drain. So this pressure here is actually at neutral, is drain. So meaning it makes sense. The cradle now is stroking. All right. So drain yellow. Okay. It's good. All right. Now. Okay, it's good, huh? So the regulation happen here. Okay, this pressure, this spring here is set to your power, okay, or horsepower or kilowatt setting based on your drive. Okay, all right. So once this spring overcome by this lever, of course by this let's say I call this a feedback piston, because there's a pressure acting, system pressure acting here, guys. Once that system pressure overcome the force of the spring, the spool will move, shift, and then what happen is, let's say P, T, A. So once that move, P and A open. So what happened is P and A, so system pressure here, all the way here, slow down. Okay, connect to your D-stroke piston, because the area of the D-stroke piston is bigger than the stroke piston. So what happened is overcome the force. So this will go, so the displacement now will regulate from maximum to minimum displacement, depend on the setting on your kilowatt. Okay, now this guy, see this, guys, what picture is this? What do you like, can you picture out what is this principle? It's too easy, guys. Okay, show you. All right, so that picture there, or that concept, comes from fulcrum. All right, or seesaw. So if you have a fulcrum point here, and then you have a force here, F2, and then F1. Okay, this is your center line. So what's that seesaw? All right, so formula. So back again to the formula principle, guys. Work Work is equals to force times what? Distance. Of course, from this point to this point, so center line, you have your S1. And then this one here, S2. Okay? So work, force times distance, or let's say Newton meter. Okay? Now, if the seesaw, okay, if you have 10 kilogram here, for this training only guys, okay. Obviously, to balance that, you have also 10 kilogram here if you have the same distance. Okay? Now, as you notice is here guys, okay, this feedback here is in this distance. Okay, so once this travel to minimum, as the spring overcome by the pressure, depend on your power curve. Okay, this is actually power curve guys. This is like this guys. Oh, alright, so this one is pressure Q. Alright, too easy guys. So let's say like that, then regulate here and then go minimum. Alright, so this is your horsepower curve or kilowatt curve, okay, or power curve. Alright, so remember kilowatt, so let's go kilowatt because it's too easy. Liters per minute times bar over 600, okay, times efficiency. Okay, so this one here, this kilowatt here, this is the one, the graph. Okay, so that curve here guys, this curve here, okay, you can set that one, that spring. So let's say I teach this already guys. So let's say you have a 300 here, and then let's say 50, and then you set that whatever that center here. Okay, so 300 minus 50, that is 250, and then you divide 2, and then you plus the 50. Okay, so okay, going back to this one. So once here, so start regulation. Okay, so at 50 it start to regulate. The displacement now is getting here. So remember, this is here. Okay, okay, now from here, from this point, let's say this point here. Okay, so that one, 300 less 50 divide 2 plus 50, so 175 guys. So I'm too slow on math guys, so I need calculator. So let's say at 175 it stopped there, and then the flow, okay, let's say 145, you're using 145 guys. Okay, let's do this. So you have a kilowatt, okay, and then you have your flow, let's say 145 liters per minute times 1000. So 145 times 175. Okay, no. So let's say your kilowatt, Q is unknown, divide 600. Okay, so let's say the kilowatt there, your available kilowatt on your drive power is only 75 kilowatt. All right, let's do that for this training only guys. Okay, 75 kilowatt. Now the Q now, okay, 600 times, so 600 times 75. Let's put 100% efficiency guys for this training. and then divide 175. Okay, so you have 257 point something, so we just put liters per minute there. 257. So here you have 257 and then 175. Okay, let's say guys at 257 flow, so this one moves here because see here it moved to minimum. Okay, because that is your max stroke, and then once it overcome it in this curve now, so of course this curve, that is your spring setting, so obviously the spring will follow this curve. Okay, so that's your set point. So at 175 bar you need displacement of 257. So how that happens, so the pressure acting here on your feedback piston push that lever, so obviously the lever will, it's kind of like that guys, see L, so the lever will push away, counter the spring, and then this one will move to the right because you have a spring here. Okay, so once that move to the right, so opening your P and A, so and then this move to minimum to 200, it will give you 257 flow rate liters per minute. Once that set, obviously you're gonna set this spring guys. Okay, once that happened, then it balance the spring force of here and on here, it balance. Same here guys. Okay, once the, let's say once the feedback is moved closer to here, so what happened is like that. Let's say this is the thing. Okay, all right, so this point here, so it stopped. So your piston now, because it balanced, so this one here stop here, and then this is F2. Okay, all right, so it stopped here. Now because it balanced the spring and the pressure, okay, what happened guys is like that guys. Oh, okay, so imagine this is the lever. Okay, you have your spring here, this is set to your power curve, and then you have your force here. Okay, let's say this is the same guys on pressure. Okay, here spring rate guys, K equals force, what, spring rate over deflection. Okay, and then here pressure, force over area. Okay, so here let's delete this, erase this. Force of the pressure, PA. Here, force of the spring, KY. Okay, so now balance. All right, so the movement now of the displacement of the pump, it gives you 257 liters per minute. Okay, and then balance. Okay, so won't stall. Now if the load is more than 175, so of course, because your point is here, this one is here already, the closer you from the distance or from the center point of the fulcrum, the more what? The more load you need so that to balance this one. 10 kilogram. This is 10 kilogram here. That's balance. But this point, so this is 0.1 and 0.2. 0.2, not 10 kilogram because you have the distance already here. So remember? So you need more. You need more force to balance here. So obviously this one here, when the feedback goes closer to your center of your fulcrum, you need more pressure again to get this point. Because this guys, let's see, that 1 point, that 1 point, that 1 point, that 1 point, that's your curve, horsepower curve. So you need more pressure here, okay, until you get to 300. And then you're as you increase the pressure, the load, the flow as well decrease, so that it maintain the 75 kilowatt. Okay, 75 kilowatt, so that this one is 75 kilowatt. Okay, this curve here. So same here principle, as the feedback piston go closer to the center point of the fulcrum, it need more pressure to balance that spring. So once it gives you 300 bar, and then obviously 300 bar, and then this spool will move to the right again, and then it will reduce the flow so that the drive power will not stall, and then you have a constant speed as well. So that's the LR, guys. Too easy. So when you see this kind of concept, this kind of drawing, remember this fulcrum or seesaw principle. It's the same. Okay? So hope you get it, guys. So the important here is to regulate the displacement of the pump so that your drive power will not stall. Okay? Kilowatt, guys. Kilowatt is equal to flow times delta P over constant, or which is this one here, 600 to become kilowatt. Because this is liters per minute and this is bar. In order to, so what is kilowatt, guys? Kilo Newton meter per second. I hope I get this. I hope I get this right, okay? Because I think the watt is Newton meter per second, so kilowatt is kilo Newton. All right. So that's why you have that 600 there. Okay. So that's it, guys. A11VO LR control, which is the power control, and that's how it works. Too easy, guys. Okay.